everybody. Sorry for the delay. We were just spending some time trying to set this up. Um, Thanks for coming today. My name is Manuel Nakamurakare, and I work at Pinterest, as you can see from my jacket here. Um, Today, I want to talk about how we brought down our build times. I'm just going to provide some general optimization tips. And here are a couple of ways in which you can contact me. That's my Twitter handle and my email. And of course, Pinterest has a booth outside, so in case you want to talk to us, you can come talk to us. All right, so this is the agenda that I had for today's talk. I want to begin by sharing what kind of build times we had before we started looking at some optimizations, what we have now, some of the main areas of investigation that we found. We classify these in three: parallelization, cache, and dev experience. And then I'm going to share the results from the optimization tips that I will talk about today. And finally, what's next, and a QA at the end. But before I get started, I want to share a little bit about Pinterest. Pinterest's mission is to bring everyone the inspiration to create a life that they love. Here are some stats. We have 400 global monthly active users, 300 billion pins saved, 3,000 employees. And as I said, we are currently hiring. We have offices in Mexico, in the US, in Seattle and San Francisco, in Dublin, in Toronto, and recently opened one in Warsaw, in Poland. So what will we learn today? So these are basically the key takeaways, the key findings that I would like people to take away from today's presentation. So we share some tools that we use in order to debug the Android build speeds, and also some tips that you can use to speed up your builds. So there will be many tips that sometimes will have some results in your case or not, but I think it's still worth testing them out. So and now let's get started with the Pinterest build times journey. So what we had before. So as you can see, here is a Slack message of a person that is kind of frustrating. Our build times used to take about sometimes 20 minutes to build. So people were obviously not very happy and kind of unproductive. In this conversation, you can see that. And these are some of our numbers that I wanted to share for some context. And also worth remembering that this was in late December 2020. So before the M1s were an option for us. So our P50 can be understood as what people will see most frequently, the kind of speeds that usually developers will get. So we were in about 1 minute and 25 seconds. And our P95 was in 11 minutes and 5 seconds. Those are, P95 is basically some of the worst build times that people can get. But still, right, like having 11 minutes or 20 minutes is still not very good. And at this time, we were not very modularized. We had about 25 modules in total, but one very big one. And I will explain later why that was a big deal. So where are we today? Now people are very excited. You can see from this Slack, this person got a new M1 laptop. They just cloned the repo and were able to build the app in just 5 minutes. And these are the most kind of recent stats. These were from March in this year, 2022. So now our P50 is 32 seconds, or 62% better compared to what we had in late 2020. Our P95 is 7 minutes and 36 seconds, so about 31% better. And now we have more modules. So now we could say that we are kind of modularized, but still there is some work. We still have one big module. So how did we get there? How was our road to get there? Well, we basically gave laptops to everybody, right? That's the solution. Just buy laptops, better laptops, and people will be happy. And that's all. That's the end of the talk. No, I'm just kidding, but really, if that's an option, try to get M1 laptops. That will help a lot. I know that sometimes it's hard to convince upper management about that, but if you are able to build a case, you can get that. However, still, right, like even with M1 laptops, someday, or maybe even today for some cases, build times might not be acceptable. So it's still worth trying to see what kind of opportunities there are in the different areas I mentioned before. So our main areas of investigation, again, it's worth noting that this happened before M1s were heavily available, so it's worth keeping that in mind. And also at that time, we still had a big monolithic app. Yeah. Before I get too deep into how we debug and what kind of opportunities we found, I want to talk a little bit about Gradle Enterprise, because this is the tool, this is one of the main tools that we use in order to debug our build scans and how we got a lot of information. So I'm not going to go very deep into detail because our Gradle friends are outside, so if you want to learn much more about it, you can talk to them. So I will just do a very quick demo about it. In this screen, you can see that in Gradle Enterprise, you're able to get some stats, like the P50 numbers that I shared before, P95, how much you save because of cash in avoidance savings. In this view, this is a view for a particular build scan. In this one, you can see the timeline, the threads that are available, the tasks that are being executed in parallel, how much time the build spent on these tasks. In this view, you can see a lot of numbers, but here I want to highlight the avoidance savings up to date, which is basically the incremental cache savings, local build cache, and remote build cache. In this one, this is a view where you can compare two builds. In this case, we are comparing a local build versus a remote build. And Gradle will tell us what kind of differences they found that prevented us from getting cache hits in this task. And that's it. So this is the first area of investigation that we did, parallelization, basically trying to execute as many things in parallel as possible. So this is what we had at the beginning of our journey. As you can see here, we can see in this slide there are 8 threads, but most of the time is spent on a single thread. You can see the Pinterest cap generates stop, Pinterest compile fast def debug Kotlin. So those were the Gradle tasks where the build was spending the most time. You can see there the build took, in this case, 7 minutes. Pinterest itself took more than 5 minutes. So it was clear that we had a good opportunity there to modularize. These are some very early wins that I wanted to share because people were getting confused. You can see the conversation here. Engineer 1 is thinking that something is buggy. The build is so fast that they don't believe it, right? Like, they get confused, but it's just that we started modularizing. People were working in very small modules, and things were fast. So we continue doing that. But even though modularization is a really good chance, it takes a lot of effort. In our case, we started working on modularizing I think it was before 2020, and we are still working on that. So it's still a work in progress. And I also wanted to say that during this road of modularization, we've also found some gotchas that I plan to share, not today because I have other things, but in a future talk, where I will share things, optimizations in a modularized world. Just want to share a couple of relevant flags in case you want to increase modular parallelization. So there is one that you can enable in your Gradle properties file, just to enable parallel Gradle tasks and one for capped. So cache, this is the next big opportunity that we identified. Incremental cache. So this is one of the types of caches where we focused our efforts. So what's incremental cache? Anytime that you make changes to your code, it should only recompile files that you change plus anything that depended on it. And this type of cache lives in the build folder of each module. How do you go about testing it? So the first step that you can take is you can do a clean build and make sure that the local or remote cache are disabled. So that's why there is this option no build cache. In this case, you can see from this Gradle scan that the build took about 17 minutes. And there were 200 tasks that were up to date. So very few percentage, less than 1%. And now you see that on the second time, now that the incremental cache has been filled up, now the time spent on builds was very fast, just 15 seconds, and now many more tasks are up to date. So now it's almost 4,000. What are some things that we did to optimize our incremental cache? So we found that whenever we were making changes in Java-only modules, the incremental cache was not working properly. And we found this bug. Basically, incremental compilation does not work with Java modules and Kotlin modules without any Kotlin classes. So what did we do about that? So in that bug, it was suggested that we add some Kotlin classes to Java-only modules, and that's what did the trick. So the results were this. Initially, before applying the fix, when they're making non-ABI changes, or even adding comments, was causing long build times. So before the changes, we were getting almost 600 seconds. After the changes, we cut it down to 128, so almost a 5 times saving factor. We also found some unexpected cases where incremental cache breaks. So in this case, we found that there were some annotation processors that had generated code, but their method order was not deterministic. So it was kind of strange because this wasn't happening all the time, just a few times, but still, right? Like you would think for people, for developers, it seemed like just randomly you were getting long build times. Another case that we found where incremental cache breaks is when modifying the R class. So anytime that you add new resources or remove them, this R class is affected. So in order to avoid breaking the incremental cache in this case, now there is a flag that you can enable, the Android non-transitive R class. Just set it to true. You might need to make some changes, some refactoring your code, but this is going to help. The next type of cache I want to talk about is the local cache. Just in simple words, the local cache tries to reuse Gradle task results when the same inputs are detected. This mostly works at the Gradle module level. If you want to test how your local cache is performing, here are some steps that you can take. So the first one is make sure to remove the local build cache. Second, in case you have a remote cache, disable it. so that it doesn't interfere with the test, and fill up the local cache. So in order to fill up the local cache, you can just do a clean build. And the third one is, now that the local cache has been filled up in step 2, you can do a you can do another build, but making sure that the incremental cache is busted again, so that you can make sure that you're testing the local cache. So what are some things that we did to optimize the local cache? So prior to optimizing our local cache, this is what we found. So this is what we got after applying step 3, where the local cache was supposed to work and result in very fast builds. But as you can see, that's not fast, right? Like, that's 7 minutes. And in this case, you can see that 29 tasks that were cacheable got executed. Ideally, that number is 0 if the local cache is working properly. So you can see here from the timeline, again, 29 tasks that are cacheable were executed, resulting in almost 7 minutes. And here's a list of the tasks that were cacheable but got executed. So as you can see, there is a theme there. All of this is related to capped. So because we saw that, we decided to test this. We enabled the build cache for capped. And these are the gains that we got. So from the 7 minutes that we used to get before enabling this flag, we ended up with almost 50 seconds. So that's a big difference. And now you can see that 0 tasks that were cacheable got executed. So that just flipping that flag did the trick. And here in the timeline, you can see again, no tasks were executed after enabling that flag. And here's a summary of the results. So again, prior to optimizing the local cache, we were getting 7 minutes and 16 seconds. But after optimizing, we got 50 seconds, so about 9 times faster. Now it's worth mentioning that these gains are visible when you try to use the local cache without making changes to your code. In case you make changes, that's a different story. Now the next type of cache that I want to talk about is the remote cache. So the remote cache, the principles are similar to the local cache. It's mostly working at the Gradle module level, but you need to have a server in order for this to work. So again, Gradle Enterprise provides the functionality, so you can use that. And usually, what people would do is you have your CI. So anytime that you land on the main branch, you want to push to remote cache, so that then when developers are building locally, they can take advantage of that. And this is how, in case you have a remote cache, this is how you can test it to make sure that it's working as expected. So the first step is you want to clear the local cache. On the second one, you want to make sure that you execute a build on CI first. So you have to make sure that it finishes so that all the cache entries are available on the remote cache. And then on the third step, you want to build locally. Again, do a clean build so that the incremental cache is not interfering. And in this case, we found plenty of issues. There were many things that needed to be fixed before the remote cache was usable. One of the things worth pointing out is be careful about values that change depending on the environment. In our case, when we started debugging the remote cache, this is what we found. So in this case, we are seeing, again, Gradle Enterprise comparing local build on the left versus remote build on the right. So in this case, the tool tells us that there is something wrong in this file. something is different, right, in the build config file. So when we saw that, we started looking at the code, trying to see what kind of things we were setting in build config. So we had this flag, right, the ECI. So ECI, as the name says, it will be set to true when you execute on CI, and set to false whenever you execute the build locally. And then another thing that we found was this property, this Kotlin option, where we set some compiler flags, also dependent on the environment. Other things that we got affected on. So whenever you are using the remote cache, you are downloading artifacts to your local environment. Some of these artifacts were very heavy. I remember we found some that were bigger than 100 megabytes. And this was causing issues because I think we have a proxy server, a server in the middle that needs to transfer our data. And just we had to increase the timeout. Another thing that we found was causing issues is empty folders. We saw a lot of these when there were a few times when we decided to change the names of our modules. So we saw a lot of these. Just having empty folders would also cause cache misses. And then the third reason why remote cache was not working on its ideal state was that our entries were getting evicted too fast. So at that time, I don't remember exactly the size of our remote cache disk size, but it was limited. I think it was maybe about 10 gigabytes what we were giving for the cache. So basically, we had to expand that, get a new machine for this remote cache. Another thing that we did for this was we limited the task that we're able to push to remote cache, because initially, every single task that was on CI was pushing to remote cache, so that was a lot. And then we just restricted it to only the tasks that are landing on the main branch and a very particular task. In this slide, you can see how we again used this comparison view from Gradle. In this case, we found that there was a folder that was only existing in a local environment, but not on the one on CI. So that was causing issues as well. And this is a plugin that was very useful. This plugin does some workarounds for tasks that sometimes find differences on the comparison tool. So they have many workarounds, and it's also worth using in order to improve the cache hits. So finally, these were the results that we got. So this is before we optimized. So before we optimized, we had 66 tasks that were different, which is why this was causing so many cache misses, and we were not able to use the remote cache very efficiently. But after we applied many of the fixes that I mentioned before, we cut it down to just one task with differences. And these were the results in terms of build times. So our build times before we did all of these optimizations were about 10 minutes. And yeah, there were many remote cache hits happening. But after these optimizations, we were able to get it down to 2 to 3 minutes. Again, it's worth pointing out that this is for a very particular use case when you try to build the main branch. And 60% of the main branch hit had successes versus 0% at the beginning. So this means that people who were trying to build the main branch, 60% of the time they were having big improvements because of the remote cache, as opposed to 0 at the very beginning. This is the last category of improvements that we found, the dev experience. In this one, in our case, we have a recommended setting for development. In this special setting, we cut down the number of languages that Pinterest supports as a platform. Instead of having 20 plus, we just have a couple. We remove some unnecessary plugins. For example, we have a plugin for bugs, but those are not really needed during development, so we disable that. We disable some unnecessary flavors. In our case, we have flavors for production, for beta, for things like that. So we disable all of them. And also, we have a different mean SDK. We found that through some tests that certain older mean SDK numbers can also affect the build times. So having a higher one just for dev purposes can also help. And of course, ProGuard, just disable ProGuard for that. And these were some of the findings that we got of this. So when people were not using the recommended settings, sometimes their builds could take up to 45 minutes. And the reason why this happened was that the default settings, or I would say the recommended settings were not the default, meaning that people, when they set up their environments, they had to enable a couple of flags. They have to choose a couple of options in the IDE. So of course, many times people didn't choose the right setting and were having issues. So instead, what we did was we just hit everything that was not necessary and just have the recommended settings by default. And whenever you had that, you would get a build for 9 minutes, which is much better than the 45 minutes. The next one, the next opportunity that we saw was remote builds. At that time, it wasn't worth for us investing. We didn't really see major gains in terms of build times. And remember, this was in late 2020, early 2021. So at that time, at least, the state of the tooling didn't seem appropriate. It would have required a big investment from our part, and we didn't think it was worth it at that time. So now we are reaching near the end. So what did we achieve with all the optimizations that we discussed today? So pre-optimization, these were our build times as measured in December 2020, so late 2020. Our P50 was 1 minute, 25 seconds. P95, 11 minutes and 5 seconds. Post-optimizations, but before M1s, as measured in March 2021, our P50 was 1 minute, 2 seconds, or almost 30% better. Our P95, 9 minutes and 4 seconds, almost 20% better. However, we had some big improvements in particular scenarios. When you were doing clean builds from a local environment, those were 9 times faster, 50 seconds. And when doing a clean build from the remote cache, those were 3 times faster, about 3 minutes. So what's next? As I think I mentioned before, so that the next, on the future, this is what I would like to share. Optimizations that we found in a modularized world. Hint, avoid recompiling unnecessarily because that produces a lot of thermal throttling. And metrics that we found useful. So we've started working on several metrics that allow us to identify where the issues could be. For example, now we track builds on CI that don't have cache. That give us some information. And we are hiring. So as I mentioned before, Pinterest has a booth outside. So if you liked any of the of the work that I shared today, please come work with us. My team, the mobile builds team, is hiring, so please feel free to reach out. And in this QR code, you can find a form where you can leave your information. I will also be outside in the Pinterest booth in case you want to talk to us after this.